Welcome back. In the last that are at right angles. But what happens if we're not at right angles? So 53 degrees off of the x-axis here, that's going to change some things a little bit. It's going to make it a little bit more complicated. Now I'm going to change this from 13 to 40 just to it'll make our numbers a little bit better. 40 miles per hour is a very strong wind speed, but it'll help us to see the problem a little bit better. Okay, so again we got this going on, and let's draw the two vectors that we would like to add. So we've got a plane and it's going 192 miles per hour straight south, due south. So we'll draw that in like this, and we've got the wind blowing at 53 degrees and it's going 40 miles per hour. So I'm just going to come in here and we'll say that that is 40 and this is 53 degrees, and we'll also label this 192. Alright, now anytime you do this, you want to make what I call the vector scorecard. So it's a T-chart, X, Y. It's not the same as the T-chart we use for projectiles. It's a little bit different. But basically there's an X team and a Y team. Each vector that you want to add, we could have like 6 vectors on here that we want to add together. We won't do that because it's tedious. But each vector that we have has got an X score and a Y score. There's 2 teams. So you can score points for the X team or the Y team. So what we want to do is just deal with one vector at a time. So I'm going to cover this one up, pretend it's not even there. Okay, now how many points does that vector score for the X team? Well, the X is horizontal. It doesn't go horizontal at all. So it scores 0 for the X team. Now for the Y team, it scores 192 points. But it scores negative 192 because on our axis system, down is negative. Alright, so we're done with that one. That's easy. We didn't even have to do any trig. Now I'm going to deal with just this vector here, and it scores points for both teams. So let's draw in our components. We'll use red for the components. So here is the Y component of that vector, and here is the X component. And we need to find out what those are. So the first video taught you that we can say that this is 40 times the sine of 53, and this is 40 times the cosine of 53. Alright, and we'll calculate that out and we'll put those as our values on here. Okay, 40 sine 53, that's 31.9. I'm going to round everything to the tenths place in this video just for simplicity, and I know it breaks the rules of sig figs a little bit, but I'm feeling rebellious here. Okay, so this is positive 31.9. Alright, and then let's do our X component. So I'll say 40 cos 53, and we get 24, and we'll round that up to the tenths place again, and that'll round up to 24.1. Okay, so the vector scorecard, that's step 2 here. Resolve components paying close attention to the signs. We did that. Both of these are positive values, so we'll leave them as positive. Now we're going to add the components on each side to get one value for X and one for Y. So basically we're going to get a total score. So I'm going to put a box down here just so I know that this is my total. So X is 24.1 and Y is negative 192 plus 31.9, and we get negative 160.1. Okay, so in the real world, what's happening here? We got this plane, it's trying to fly south, all right? But the wind has got this component right here, this y component that is opposing that. So I could also go over here and draw that y component. And now you can see over here these scores, how this and this are opposing each other, hence the positive and negative. And the difference between them is that. All right, now in the x direction, we have this component, and that's what we're going to use down here is our total score. So on a new set of axes, we're going to draw the components of the new vector. All right, so I always start with x when I do this. So I'm going to go over 24.1, and then instead of drawing the y component from 0 like we've been doing, I'm going to actually go here and draw this, and this is 160, negative 160.1. And the reason why I didn't draw it right here is because now I can draw this triangle in here, or the hypotenuse of the triangle, and this is my total velocity vector. So what I just drew here in blue, that's what the plane is actually doing. Okay, it's velocity is in that direction, and it makes sense. Okay, because this x component is throwing it off course a little bit. All right, so now we need to figure out what this vector's value is. That's the point of vector addition, is to figure out your final vector. So now it's just stuff you've already done. We're going to do Pythagorean theorem, and then we're going to find the angle. So if you want to pause it, try it on your own, and then check your work. That would be a good idea. You can pause it right now. All right, let's check and see how you did. So, Pythagorean theorem. And notice I dropped the sign on that because a negative squared is a positive number anyway. 24.1 squared plus 160.1 squared. And we'll square root it. And we get 161.9. So 161.9 meters per second. That is this value right here. Okay, but we have to give the angle because these are vectors. We can't just say this, we have to report the direction. So what I'm going to do is find this angle, and then I'm going to subtract it from 360, and I'm actually going to give this angle right here. Okay, so I can do this a couple of ways. When I do this, I always drop the negative sign. You can leave it in there if you want to, but it can get kind of confusing. So I'm going to say that the tangent of theta, and this is theta for now, is equal to my opposite side, which is 160.1, over my adjacent 24.1. And then I'm going to inverse tangent. So second tangent 160.1 divided by 24.1, and we get 81.4 degrees. I'll round to the tenths again. Theta equals 81.4. Alright, now since I dropped the negative sign, my calculator thinks I'm working over here. Okay, it doesn't know that we're down here because I didn't put in the negative. Alright, so what I need to do here is subtract from 360, so I'm going to say 360 minus 81.4. And we get 278.6, which would put us in the right quadrant down there, so we're good on that. And now I just have to report my final answer. So I got 161.9 meters per second at 278.6 degrees. And we could round it all for sig figs if we wanted to. Alright, but then we'd have one sig fig in our answer. So I'll leave it as that. That's my total vector. Now you can see this is a little bit more of a process than before, and it's because we have those angles. Alright, so you've got a little worksheet. It's the little half sheet. There are 3 problems on it, but before you try that, watch the video where I'll walk you through one more of these, and this one will do a lot of pausing and you can try some stuff out and then check your work. Alright, thanks for watching.